Yeah, but you can't.
Oh, okay.
Order operations is you don't multiply before you do exponents. Roots are exponents, so you can't multiply these two negatives together, so it's not real. Yeah. So what did you do?
Nothing right.
Oh, scheisse. All right. This is going to be hard to stop yourself. If you see 8, rad 7, minus 6, and you do this, are you right? No. Right. It's the same thing as saying 8x minus 6 is 2x. Now, we all know that's bullshit, right?
Yes.
I haven't seen anybody make that mistake in a long time. So that's automatic now in our heads. Of course that's not 2x. I got 8x's minus 6. How could that make 2x's? I didn't lose any x's. Same thing here. I got 8 of these. Minus 6. Did I lose any rad 7s? No. Those aren't like terms. I can't put those together. So if you see a problem like this, can you do anything in here? And if you said you could, I'm like, what did I just tell you? Yeah, we can't do anything in there. They're not like terms. So of course, what do you do with this? Distribute? Yeah.
I see where it is wrong.
Sorry. Yeah. So it felt like I was trying to, it felt like I was trying to make you do something here, but no, the whole point of this was a distribution problem.
Okay.
Yeah.
Makes sense.
But you weren't alone in making that mistake, so I'm just picking on you. I'm picking on as many people as I can. Oh, sure. Dylan. Yeah. Practice test. All right, guys. So everybody's got a practice test, right? A few more people came in. Everybody's got a practice test. Okay. So 1D on the practice test, there's a giant mistake you could make. Just remembering that radicals are exponents. They're just some, according to your really weird math teacher, they're a really bad way to write fractional exponents. And I know that exponents don't play well with addition and subtraction. I mean, if I ask you what's x minus 4 squared, I think that most of you wouldn't say it's x squared plus 16 or something, all right? What did I do wrong there? What am I supposed to do with this? Write it twice, FOIL it, get my middle term. I can't just let the square go to both because the square won't play well with subtraction. No exponent will play well with subtraction or addition because they're not based on those. Square root is an exponent. It's a 1/2 power. Is it going to play well with? No, you can't just square root this and square root that and then just stare at that for a minute. Somebody always tells me this. The answer is this. No, you can't do that. So what the shit do I do then? Yeah. So that factor's like?
X plus 6 to the second.
I like it. And then of course the square root of the square. Mostly cancel, right? Why do I say mostly? Because the answer is not x plus 6.
Equal.
All right, you gotta cover your ass.
In what case is it not absolute value?
If the instructions say you know that there's no negative values inside. Yeah. So this x could be anything. So if x was -7, and I didn't put that down, I'm saying a square root equals -1. That can't. So I'm covering my ass for not knowing what x is. I got to make sure it comes out positive. Well, what's x? I don't know. Just make absolute value of it, so it's always positive, no matter what. Like it. And real quick, let me see if you guys, I think I've gotten you to the point where it might be almost kind of second nature to do, what do you do here exactly? How do I solve this? Square root? Yeah, so I think I've gotten everybody, I've at least got room to this point, but I think I've got everybody where that's an automatic. Right? Yes? No? Maybe. If not, get there. But here's the real story. Here's what I sort of skipped, so it didn't look too freaky. Square root of x squared is absolute value of x. And how do you solve this? What happens with absolute values? You always get two cases. Yeah, 9. So when I take the square root of both sides, there you go, Jeff. So you get x equals 3 or negative 3. So this is just a shortcut to doing that. You don't actually show yourself the absolute value. You just make it a habit to put the plus or minus down. So that really is where that plus or minus comes from. It's because the square root of x squared is the absolute value of x. And that's got two cases. There you go. I like it. I just don't like teaching it this way so you don't feel like you have to do this. But that's where that plus or minus really comes from. Kick ass. Yes?
Number 3 on the practice test, find the domain of each function. I had a problem with B.
Number, which one, sorry?
Number 3, find the domain of each
Oh, yeah.
function.
You had trouble with B? So what's the root on 3B? What's the root? Which root is 3B? What? You're looking at the practice test, right? Practice test?
Yeah.
What are you looking at?
Yeah, the
Practice test. Okay, so 3, right? 3B? 3B. What's the root? Yes. What's the root in that function on 3B? What's the root?
There should be 4, right?
No, I mean, what does it say? What's the function?
Find the domain of
No. What is 3B? What is 3B? F of x equals, right?
Equals to square root?
No.
No?
3B, right? 3B?
Yeah.
It's not a square root.
Well, it's not a square root.
See, that's my point. Okay. Why is that so freaking important when it comes to domain?
Because there's an odd,
Yeah, which ones are the uptight ones, even or odd? Even, can't handle negatives, can't be negative at the end, they just freak out. They become these awesome complex numbers. That's probably not the word you'd use, but we don't like to think about them, we don't have to. And if I just say find the domain, it's understood to mean real stuff.
So it's all real numbers then?
Yeah, since it's cube root, can it handle everything? Yeah, it can handle negatives. Cube root of negative 8 is negative 2. And does everybody see why? When I have 3 negatives, the answer is still negative. So the answer sign matches with the original sign. 4 negatives, the answer is positive. They don't match anymore. You can't go back and forth. That's why even roots freak the shit out with negative stuff.
I have a question.
Yeah.
Okay,
Is that right?
Yeah.
Okay.
So if the root is odd,
Yes.
it's all reals but.
Oh, careful. If the root is odd, the root has no problem.
Okay.
Why was this all reals? The root had no problem, and 3x plus 2, he's cool
If
everywhere.
the inside is positive, then it's all reals?
No. Okay, be careful. Is the inside of this problem positive?
We don't know.
Don't know. Beautiful answer. Don't know. If x is 1, yeah. If x is negative 1, no. Do you see that? 3x plus 2 is a line that goes negative to positive, doesn't it?
Can you give an example where the root would be odd, but then you'll still have to work on the problem?
It's 3C.
Yes. 3c is a good example of that. What was that? 3c is the 5th root or something?
7th root of
7th root, dude. Yeah.
2 over x minus 6.
So does the root have a problem? No, it's an odd root. He's laid back. He can have all kinds of shit. The inside is the one that's got a little tick, a little neuroses. He can't handle.
Can't be 0. The denominator.
Denominator can't be 0, so that means x can't be 6. So x can't be 6. Not because of the root. What's the trouble here?
Okay, so on the quiz, you know
Yes.
on number 1B,
Yes.
there's an odd root, but then the inside was negative. I don't get the difference between this and the.
Okay, so the point of what this is saying is that any number in here is cool with an odd root. So what's the cube root of negative 27? It's allowed. The answer isn't no, real answer is something. It's within its wheelhouse. It's in its domain. It can do this. What does it take 3 of to make negative 27? 3 negative 3s. So why can't I do the square root of negative 9 then? Because negative 3 times negative 3 is positive 9. Another negative 3 makes it negative 27. See, so the odd roots, I call them laid back, but they're sort of lucky. Every odd one is going to become the sign again, the correct sign again, and then it's going to become positive, and it's going to become negative, and it's going to become positive. So that's why the odd roots work.
So an ask to repeat that.
Oh, shit. Okay. All right. Sorry, I was thinking I could somehow rewind it on my... But, so watch this. So what is negative 3 squared? 9. What's negative 3 cubed? Negative 27. Right. And what's 3 squared? 9. Oh shit. And what's 3 cubed? 27. See, there's a difference here, and there's no difference there. Does anything come out to be negative 9? So if I say, what did it take 2 of to multiply into negative 9, it's not real. There's no real number that'll do that shit.
Yeah.
But when I say, what's the cube root of negative 27, that would be, negative 3 makes that happen.
So for negative 9, I would put undefined.
This would be not real.
Okay.
If I say you can't use complex, but what is the actual answer? We know now, we're better than this. It's 3i. Yeah.
Since we're like crushing the domain stuff, can we just go over 3A?
Yeah, sure.
And 1 of 5.
And what now?
And 1 of 5. Like, just one of them.
Oh, I didn't say 105. I was like, how big of a freaking practice
Oh, yeah.
That was
Definitely some of the back.
on something. So 3A is one that involves, some work, right? What was it, 7 minus 2x? That's an even root. So the root has issues. Even roots have issues. What's got to be true about the inside? Yes. The inside has to be greater than or equal to 0. Some of you guys, I kind of like this. Some of you guys think you're supposed to do something to this. No. The idea is the inside must do something. That's why I'm not looking at the square root part. I didn't do something. I didn't square both sides. No. The inside. That's all I'm caring about. The inside has to be at least 0. That's what must happen for this to be cool. Right? To not become freaky, complex. So if I solve this, I see all the values of x that make that happen. But don't let it be complex. I like it. So all you got to do is solve this thing. You got to be careful. You got a negative. You're going to have to flip the signs.
When doing a problem like that, how do you determine which way the sign's negative?
So for domain questions about roots, it's always greater than or equal to. Always.
Always?
As I work this problem out, what is going to happen because of the work? It's going to flip.
Oh, okay.
Because I'm going to divide by a negative.
Okay, then I got it right.
So how do I always set this up? Domain question about an even root. Inside at least 0, greater than or equal to 0. The work might flip the sign, but that's could happen. That's how that works.
Do we give our answer as a ordered pair?
Can't be an order pair because then that's saying 1 point, 2 space works. It's not. I want a bunch of inputs that work. So it's going to be like an interval notation. This might be what you're saying.
Right. So x is less.
Yeah, if you add 2x and divide by 2, you get there. And then I would accept this because I didn't say put it in, but you could also put this, right? at.
Say it one
Oh yeah.
Just five.
Yeah, okay, so this was in the homework. And nobody asked about it, so. But let's look at this. Let's kind of build this up. Let's kind of build our way up to that. If I just look at a square root by itself, let's see what this thing looks like. And when I'm about to graph something, we now really understand this more than I did at this level, to be honest, because I'm showing you more shit than my teacher did. When we graph something on an XY plane, that is the real slice. I like that. It's the real slice. There's no complex shit. So that's why the first step is to figure out the domain of this. What real value, what's going to end up with real value. So what's the domain of this? This is a nice one.
X is right there.
All right, cool. So when I go to make my XY table, which is how you do it when you have a function, you're not sure what it looks like. What's the lowest number I'm going to use? 0. So that's why I ask you first, find the domain, because then you know what numbers you're allowed to use. So if I put a 0 in, what's the square root of 0? 0. Because what does it take? 2 of them multiplied by 0. 0. What's the next good number I can put in? 1. So square root of 1. 1. And since I am graphing this thing by hand, I'm not going to use 2. I'm not going to use 3. I'm, of course, next going to use 4, because the square root of 4 is easy to graph. Right? Rad 2 is 1.414, blah, blah, blah. Graph that. No. I can handle 1 and 2. So here's what every square root function fundamentally looks like. Some of them might move it around. We saw with the absolute values how you can move that shape around. I don't know if you guys remember that. But here's what it looks like to start off with. 0, 0, 1, 1, 4, 2. Now, does it look like a shape to anybody that we kind of know already? To be honest, it's supposed to be more pronounced down here. Doesn't it look like half of a parabola?
Yes.
Why does that make sense? Because the square root of x is the opposite of x squared. So it's sort of like a parabola fell over and then lost its bottom half. Why did it lose its bottom half? Because this cannot come out negative. And the bottom part would be all the negative shit. So it's like, oh, just fell over.
So, is the idea of when you're graphing and trying to find plot points to use inputs that are going to work?
Totally.
in your
I don't know if you guys remember, but I know we saw something like this earlier. I'm not going to put 2 in there. I'm not going to put 1 in there. I'm going to put 3 in there, because that makes a nice whole number come out. I can be smart about the values I use. Because how many values do I have I could use? Infinite number. But do you want to put 2.764999993 in there? No, I don't want to do that. I'd rather get some and then I hit that point. Bam, I hit it there. I already did it. When I graph it, I get all the other shit I could have done. So the 2 on your sheet are going to look like this shape. They're just going to be moved around because it's not just x inside. So what's that first one? It's what was it again? 2x plus 4. Okay, so let's see. What's the domain? How do I figure that out? Greater equal to 0. Subtract 4 divided by 2. I get that, just to kind of cut to the chase. And now when you go to make your XY table, it's the smallest value you're going to start with. -2, because that's what my domain starts there. So I can't use anything below -2. What do I get when I put a -2 in? You should know. We're going to get 0. Right? But when you put a -2 and -4 plus 4, it's 0. Now, what is interesting, can somebody see the next good number to use? 6 is a good number, but it's not the next good number. 0 is good.
0, yeah.
Why?
Because then it's square root of 4.
Because then it's square root of 4, which is 2. And watch. Now that we know the shape of it, a square root function will always have this shape. It could just be moved around and reflected and shit. If anybody takes pre-calc, you're going to do a lot more with moving functions around and mirror reflecting them around axes and shit. Yeah. So I got -2, 0, 0, 2. And that's all I need if I know the shape. I need a lot more points if I don't know the shape. But we know the shape now. So just fill in the shape. Hi! So it's the top part of that parabola. The other one, 5b, is a cube root, right?
So you can use any one.
So you can use any number. So now you just want to plug values in that end up with a -8 inside, or a -1, or a 0, or a 1, or an 8. Numbers that you can actually cube root so they come out whole. Does that make sense? I mean, we could be smart about what we input. Because we're the ones that have to graph the results. Why give ourselves disgusting things to graph? That's just you being mean to yourself. You made a hard test. No, I didn't. You made it hard. Sorry. Yes?
Can, on the practice test, something like 3C?
Oh, we did that one a minute ago.
Oh,
Yeah.
sorry.
What root is it? Odd.
7. Oh, so
Has
it's
no
all the
problem.
numbers?
Except the inside's got a problem. What's the only number you have to throw out? What can be inside
Or
that?
the 6 could be a 3. I mean,
What's the only x that freaks the inside out? What makes the inside go 3?
oh, 6?
Yes, so x can't be 6.
Oh, that's the answer?
Yeah,
Oh.
so it's not the root's fault. The root's cool with everything. It's just the inside's like, oh, don't use 6. It's going to make
Okay.
me go to infinity and create a black hole. Don't do that. That's what they mean when they say the singularity. You guys ever heard that? Singularity is more generally, it's in an equation where something is divided by 0. So in Einstein's equations, he discovered that just happens naturally, and he said, oh, this is a physical thing, and that's what a black hole is. A black hole is what happens when you divide by 0. So don't do that shit, right? Don't make a black hole in my class. I'll get in trouble. Sorry. Anything else?
1C.
Yeah, okay. One of the biggest mistakes, I'm not picking on somebody who said to do this earlier, because this is what a lot of people do. What is wrong with doing this first? What's wrong with that statement?
You have to put an I.
No. Just, what did the person do?
They took out the negative.
They forgot about the -1.
What'd they do?
Oh, they multiplied it.
Yeah.
This one, which doesn't.
But what does order operations say you can do first? Can I multiply first, or do I have to do exponents, which are what roots are, first? I do exponents first. So I can't do that shit. These negatives can't cancel because that would be multiplication. I'm not allowed to multiply before I do roots. Roots are at the same level as exponents because they are exponents. Yet another reason why it sucks we made this other symbol, because then we forget where they are in order operations. But they are powers. So officially on that first problem, I say only using real numbers, so the answer to this is not real. But if you wanted to, what's the answer to the square root of -16? 4i. So the answer is negative
4i.
4i.
You said using real numbers now?
I did. So, I mean, right here you could say not real, and I do on the answer key. But if you put -4, I'm not going to take points off for a correct answer. That's fine. Yeah.
Did you do a quadratic formula problem?
Yeah. Let's see. Let's do another one of these because I will tell you right now I'm going to put this on the test. That should wake some people up. Let's see. So if I say solve this, and if you only get one answer, you know you're wrong. Because because Jeff has made a big deal out of this. Why did he make such a big? It's called the fundamental theorem of algebra. Holy shit! How many answers does there have to be? 3. I like it. And this is probably a little too much, but do you guys remember when we were talking about the I stuff? Remember? And that's the I axis. The 3 answers are all equally spaced away from 1. So there's an answer here and there's an answer here. They're all equally spaced. It's like taking, how many degrees total is there if I move around the whole circle? Total circle has how many degrees? 360. So one answer is going to be -3. Can you see that one answer is -3? -3 cubed is -27. So one answer is -3. Actually, it's going to be the opposite of what I just said. And the other answer is going to be 120 degrees this way away and 120 degrees that way away. Okay, that's too much. That's way too much. I'm sorry. But it's been in my head. I wanted to tell you that because that's the whole real picture. And you guys have been getting answers like this, so this isn't that big of a deal. But when you see an answer like 1 plus I, that is actually a point right there. That's 1 plus I. 1 plus I. So if I have answers that are part way here, they're going to be like 2 plus rad 7I or something. They're going to be some combination. Okay, that's way more than you have to know. I'm sorry. If you want to go tell somebody, our teachers tell us too much. So what do you really have to know for this problem? You just, how do I factor this? We'll do big dude, right? It's cubes. What goes in the little dude? X plus 3. And then I need the other 2 x's and the other 2 3's. And then what's the middle sign? Minus. Yeah, 3x. Sorry. So here you can see this is where you're going to get the -3. Bam. There's the nice real answer. This is where you have to use what? Can't factor the big dude, ever. So to solve this equation, you have to use what? Whose job is it to solve ax squared plus bx plus c equals 0? Whose job is it? Formula. That's his job. What's quadratic formula's job? Ax squared plus bx plus c equals 0. Solve it. That's what he does.
You have to move the 9 over.
That's completing the square, which is the long cut.
Okay.
Quadratic formula is completing the square shortcut.
Okay.
So if I just say solve and you complete the square, I'm not going to take points up. But if I say use quadratic formula and you don't, you're going to lose points. A lot of points.
I'm confused. Is this the one where you divide it by half?
That's completing the square. So I really want you to understand, how did we create quadratic formula? By completing the square on every possible problem that looks like this. So it is completing the square, but it's like we've already done the completing the square steps. We just have to fill in what the numbers were. So let's do this both ways. It'll be a good review. Let's do it completing the square, and then we'll do quadratic formula. So let's look at this bad boy over here. So the other piece I got to still solve is this piece equal to 0. So how do I do completing the square? Like you said, I got to first.
Divided by 2? Or divided by half?
First step is to split the middle. Oh, to move the 9.
Oh, move
Yes,
the
make some room. Sorry. Make some room. Now,
Divided by 2.
divide what by 2?
The middle.
The middle. Okay, so first step is take -3, cut it in half. Second step is take that and square it. What's -3 squared? Mm.
9.
Hmm? 9 fourths. Now, I think you said I, right? It's okay, Ruth. Don't freak out. Because there's all this kind of shit in our heads. The only place I could come from, well, it's Georgia, but the only place that the letter I could come from is from a square root. Or more generally, any even root really, but we focus just on square roots because otherwise it gets way too freaky. You guys with me? So if I'm squaring something, ain't no way the answer is going to be I. Right? Unless there's i's already in there somewhere, right? So I'm squaring a number, it's going to come out positive, so it's all good. Right? Okay. So it's negative when I square it, it becomes positive. That's it. Doesn't matter. So what do I do with this guy?
Insert.
Insert it where?
Right there.
I was going to say be gentle. I guess I just. And then, it's not with question.
Or add.
X minus 3.
Yes, I know how to factor this. Remember, the whole purpose of completing the square was to put it in this form, so then I can just square root and do that very directly, right? So how do I factor this? Yeah, the first step tells you what to put in there. Bam, don't have to think about that at all. Okay, so you guys look very concerned. If you've missed a lot of class, you should look very concerned. And then over here, what do I have to do? So he needs that. So you get negative 36 plus 9. Negative 36 plus 9.
46.
Let me show you something. I want you guys to see this. This is cool. This happens enough in math that it's very useful. Now watch this. If you don't get this, it's okay, because you don't have to look at it this way. But if you do, it's awesome. Isn't this negative 4 nines? Right? I can read that 4 nines, right? That's what 4 times 9 means, 4 nines. Negative 4 nines plus 1 9 is negative 3 nines. Well, what's negative 3 times 9? Negative flipping 27. Oh, shit. Oh, snap. So that happens, now the last people I told was my calculus students. I didn't want to say that at first because it's not calculus level shit. It's just something to realize. And again, it's not that big of a deal. If you don't see it, just do it. Over 4, right? Okay. And then I square root. One semester they would just make me like almost collapse. What's the matter with him? Plus or minus? Alright, now what the hell? There's a lot more you can do on that side than you think. Here, I'll do the bottom. Oh, thanks, Jeff. You guys take a minute and figure out the top. There's 2 things you can do at the top. Yeah, one of them is obvious, that negative, but the other one is the fact that it's 27. So square root likes a piece of that. Right? He's just staring at me. I don't know. Is that how you do things? Are you doing it in your head?
You do 1/2 and then you leave a part.
Where you break it up?
Yeah.
So the negative will become I. We'll do that. Right? Get that out the way. And then I got rad 27, right? But 27 is 9 times 3. What's the square root of 9? 3. And what's the square root of 3? I don't know. Third base. And then you just have to add 3s. Now let's do this again with quadratic formula and see which way you like better. I do too. So, let's rewrite what the problem is. We have this. One really nice thing about quadratic is there's no needing to make room. I'm not going to do shit to that. I'm going to use the numbers I see there, right? What's the quadratic formula itself?
Negative b plus or minus square root of 4ac.
Square root of b squared minus 4ac over 2.
So you're reading that from notes, which I don't think you were, which is good. You were. Oh, you better know it. You know, why don't you write that down? You gotta just know this shit. I'm going to be senile, 92 years old, walk around, negative b, push back. That's going to be all I've got. So what's b? Yeah, so let's put that down. So a is 1, b is negative 3, c is 9. Now it's just a bunch of plug and shove. We did it for all a, b, and c. That's the answer. That is the answer. I just have to plug in the numbers for this situation. How did we get this answer? Completing the square. So quadratic formula is a shortcut to completing the square. So this will be negative 3, so it's 3, give or take, square root. What's negative 3 squared? 9 minus 4 times 1 times 9. All over twice 1. And I just gotta simplify. Nine minus 36 is negative 27 again. Didn't we have that earlier? Remember that? And then you take care of that the same way we did. And we get the same answer. Alright, this is just written in 2 parts. That's written together.
And I like the quadratic formula.
Yeah. I'd say 80% of the time, quadratic is faster. There are some problems, especially when the numbers are really, really nice, that where completing square is actually a little bit faster. So what's the best way to bet? Quadratic formula, yeah. It's designed to be a shortcut. Okay. So you have to know how to do both. Yeah. Because they both do show up throughout all of mathematics.
So, oh.
That was a good. What's up?
So I can't.
Oh, normal distribution, fair normal distribution.
Oh, are we not doing 8 on the practice stuff?
Oh, 8. 8 is from that. I can't remember what section, but yeah, we didn't quite fully make it there. We sort of looked at it because remember that all that section really is if this comes out negative, you're going to get complex answers. Right? If it comes out positive, you're going to get real answers. If it comes out to be 0, you'll get 1 answer, because why do you get 2 answers normally, the plus or minus? If that's 0, you get 1 answer. That's when the parabola would sit on the axis. That's the one time you get 1 answer. Then you might say, doesn't that violate your fundamental theorem there, Mr. Math Boy? And I'm like, no, because you get this answer twice, man. Sorry. That would be like x minus 5 squared equals 0. Well, the answer is 5, but how many times does it show up? Twice, man. It sounds like, anyway, it's the real thing. It's called multiplicity 2. Shows up twice. That's a nice collection of math right there. I like it.
Pretty big. So are we going to have to do both completing square and quadratic?
Yeah, just like that number, is that number 7? That's got
7A and B.
Yep. That's the kind of question I like to ask you, is to have you do the same problem both ways, because then if you like a way, you should know what the answer is supposed to be. It should help you with the way you don't like it.
And do we have to memorize that formula in order to do it?
Do you have to memorize this formula, guys?
Yes.
Yes, unless you have a different way of doing it, but the only different way I can think of is to have it to cheat, and you don't want to do that. So you probably want to memorize this bad boy.
7B, the leading term, is a negative 2.
Yes.
Is that,
So A is negative 2.
yeah.
See, that's another beautiful thing about quadratic. Whatever the number is, you just put it in. If it's negative, put it in. Right? Something else, too, I want you to realize. What if I ask you to use quadratic formula to solve this? Let's see if anybody... There's an equivalent equation that will have 0 fractions in it that I can solve that will have the same answer as this one does. What am I allowed to do to both sides of an equation? Add, subtract, multiply, divide by the same thing, right? So what I'm going to multiply by? Yeah, because I can make this 15, right? Make this 15. And then I can multiply both sides by 15. 0 don't give a shit. And then this becomes x squared. This becomes 6x. This becomes, oh, that looks so much better. Not 15, Jeff. That looks even better. And then, and now, you can't factor that. 6 and 5 are kind of evil, but 5 and 1 would make 6 if they could be the same sign. But they can't, so quadratic is the way you have to go. So don't just, if it's an equation and you don't like a part of the equation, you know we've developed ways to get rid of the shit you don't like. So could you make A 1/15 and B 2/5 and C negative 1/3 and have it work? Yeah. Well, it's going to look ugly. But it will work if you do it right. Would I do that? No. So this is something, you know, my calculus students, they don't even watch their own videos. They're not going to watch this. Something I kind of get on my calculus students about is you got to get used to simplifying the problem you're given before you start to attack it. Especially important the higher up you get. If you make your problem look a lot simpler and then you start to attack it with some process, that the process should go smoother. Right? Maybe. So you're supposed to start getting used to that now. Okay, anything else?
So we just do 2D.
Yeah, all right. A good idea with 2G, see how inside you have a mixture of numbers and variables with exponents. And can you do anything on the inside? Because that's, of course, order operation says to do that first, but really there's nothing I could do on the inside. So here's how you can be really nice to yourself. I'm already being mean. You don't want to be mean on top of that. Can't do anything in here, really. So what do you do with this? Distribute it. So the 8 gets it. What do did I write that down? 2/5, yeah, thank you. I knew something was right. What do you do with these powers? Multiply them. I was angry and sad. And then I multiply these. What situation would I add to exponents if I was multiplying like bases? Then I add the exponents, right? That's not what's happening here. So now I got a little problem here. I got a little problem here. I got a little problem here. That's what I mean by breaking a problem into smaller parts. Each part is easy. Nobody said you had to be able to do the thing you have to do in your head. Write down what the hell you're supposed to do and then do it. If you don't want to, it's fine. If you do it in your head, it's great. So here, what do I do with this? Yeah, put it under 1 because it's flipping. And what's the root? Cube root of 8 squared. That's that piece. What happens here becomes x to the
-4.
and this becomes, yeah, that's nice. So then you got to finish this up. He's going to want to go, and he's just sitting there. He's done. What's your problem? So now I want you to realize something. What's going to be on top in the answer? He's the only thing on top. He's on the bottom, and then he's on the bottom, right? So whatever this number is, plop it. This guy wants to go down. All me go ahead and give you guys the answer key. I have time to double check them in. Make sure I got them. I just didn't do number 8. The next test is actually going to be the final exam. Can you believe it? The end of the semester is coming. I don't know. It's on the homework sheet. That's why I put it there, so I don't have to carry it up here.
Is it cumulative? Sure.
Oh, hell yeah. Cumulative final exam, which is what's supposed to be true about every class on campus, but some teachers, they don't care about doing things the right way.
Yeah.
Yeah. Yeah.
So this will be our last test, and the next one will be the final?
We might have one more quiz before the final.
So we'll have time to kind of review everything.
Yeah, I'll have a practice final with an answer key, just like tests, yeah. There also will be workshops, like final exam review workshops. So I don't know right now who's going to be doing the workshop you guys could go to. But I'll try to let you know. Hopefully somebody can do it. Otherwise, I'll have my own little workshop just for you guys, in class. So here's something that I didn't go far enough with this, the graphing thing, but I want to show you. This is kind of nifty. This makes sense about why the cube root looks the way it does. Square root looks this way because it can't exist back here. So it's got that shape. If you give this answer to me when I ask you to graph something, you're going to lose basically all the points because you ain't got no scale there. So it's good to know the shape, but you better put that on top of some kind of scale. So cube root of x is allowed to have negative inputs. And if I have a negative input, the output will also be negative. So it's got kind of like this cool mirror image thing going on back here. That's the negative input, negative output part that this guy doesn't have because it's not allowed to have negative inputs and negative outputs. So they actually are the same graph, it's just that this one has that mirror image down here. And just in the keeping of the theme of the day, I'm going to push that one step further, and this has got what's called origin symmetry. It's like there's a mirror through the origin. Because not only did it flip this way, it flipped that way too. Do you have to know what I just said? No.
I see what you mean.
Thank you, Dylan. Dylan's like, yeah, at least humor. No, if you can see it, it's good. If not, it's okay. You don't have to worry about it yet.
Our next test will be when?
When's the next test? Tomorrow. That's why we're...
You're not gonna give us time to do the quadratic formula and the completing the square?
What do you mean, give you enough time?
No, I mean to review it and stuff like that to really get it, because I don't know if it's just me, but I think it's a lot of process.
Yep. So I hope we can do it by tomorrow. If you think that's me, it's just too bad. It's the way we've been doing it the whole semester. I never quiz you or test you on something we've learned the day before that day. That's why I always have this review day where we don't learn anything new necessarily officially. Right? I understand homework is a bitch. I understand, but you have to do it. And the whole thing is, if you're really behind, then you start doing every 7th one or something, right? and then you finish it if you can later. Because what's the whole purpose of me assigning homework in the first place, and you doing it, is to get ready for the heaviest weighted stuff, the tests. The only reason I make homework worth anything is because otherwise, as I've learned, nobody would do it. And I can't really blame. I'm like, the homework that counts or the homework that's not worth shit? I think I'll do this. That I understand. That's the only reason I make homework worth anything. So it's really the purpose is to get you ready. So if you're like you haven't started doing any of the chapters with completed square quadratic, just start doing every other or something, right? Just to get some practice. Yeah. It's chapter 10 up through section 11. So 10:1 through 11. Actually, it's through 11:2. 11:3 is that thing where I was saying, how do you know there's going to be real answers or complex answers? Yeah.